Hi students, now we are going to go for the third problem of trigonometry exercise number 11.1 Telangana state syllabus book. Okay, so now here it is given in a right angle triangle ABC with a right angle at B in which A is equals to 24 units and B is equals to 25 units and angle BAC is equals to theta, then find cos theta and tan theta. So for example, if I am taking this as a right angle triangle, A, B and C, this is 90 degree at B as it is said. Now the side opposite to vertex A is called as small a and it is given as 24 units, and the side opposite to vertex B is given as small b and it is given as 25 units. Now we need to find out this AB. Okay, so for this we have to use Pythagoras theorem. So what is given? First you write down here, given triangle ABC in which angle B is equals to 90 degree, that is A, which is equals to side BC, that is equals to 24 units, and B, that is equals to side AC, that is equals to 25 units. Okay, now by using, since it is a right angle triangle, so we can find out the value or the length of AB using Pythagoras theorem. So by Pythagoras theorem, I can say hypotenuse square, that is AC square, will be equals to AB square plus BC square. Okay, so now here AC is given as 25 square equals AB, we have to find out, keep it as it is. BC is given as 24 square. Okay, so we will be getting this as AB square. I am transposing 24, so it will be 625 minus, it will be 576. Okay, so this gives me 625 minus 576, we should be getting as 49. So AB will be square root of 49, so AB will be equals to 7. So we got this as 7. Now he is asking to find out cos theta and tan theta. Okay, so accordingly cos theta, cos ratio is adjacent over hypotenuse. So for theta, theta is given as BAC. So this angle is theta, and so this is opposite and this is adjacent. Okay, so adjacent is AB, so it will be AB over hypotenuse is AC. So AB we got as 7 and hypotenuse is 25. So this is cos theta. So we are finding tan theta, that is equals to opposite over adjacent. So opposite here is 24, that is we'll say the side BC, and the adjacent side is AB. So that is equals to 24 over 7. So this is what we were asked to find. Now the fourth question we have is, if cos A is given as 12 by 13, find sin A and tan A. So first I'll draw the figure of a right angle triangle. This is my right angle triangle. This is A, B and C, vertex A, vertex B, vertex C. I'm taking 90 degree at B. So for angle A, this will be opposite, this will be adjacent and this will be hypotenuse. So when it is given cos A is equals to 12 over 13, So it will be adjacent over hypotenuse. So there is 12 and this is 13. So by Pythagoras theorem, we have hypotenuse, that is AC square is equals to sum of the squares of the other two sides, AB square plus BC square. Okay, so AC is given as 13 square is equals to AB is 12 square plus BC square. So 13 square 169 minus 144, I am transposing this and taking out the values, is equals to BC square. Okay, so 169 minus 144 will gives me 25 equals BC square, or I can say BC equals root of 25. That implies BC will be equals to 5. So I got this as 5. Now I have to find out sine A. Sine is opposite over hypotenuse. For angle A, opposite is BC and hypotenuse is AC. So it will be 5 over 13. For tan A, tan is given as opposite over adjacent. Opposite is side BC and adjacent is AB. So it will be 5 over 12. Oh, this is the answer what we get. Now my next fifth question is, if 3 tan A is equals to 4, find sin A and cos A. So solution, I'll change mine to so given 3 tan A is equals to 4. So cross multiply 3, so it will be tan A equals 4 over 3. Okay, now if I take the right angle triangle A B C, 90 degree at B, this is my angle, so this is opposite and this is adjacent and this will be hypotenuse. So tan is opposite over hypotenuse, so this will be 4 and this will be 3. So by Pythagoras theorem, I can say hypotenuse square is equals to sum of the squares of the other two sides. AC I have to find out, so keep AC square as it is. AB is 3 square plus 4 square. So AC square is equals to 9 plus 16. This gives me AC square equals 25. So AC will be equals to root of 25. AC will be equals 5. Now sine A. Sine is given as opposite over hypotenuse. Opposite is BC and hypotenuse is AC, and AC hypotenuse I got as 5. So it will be 4 over 5, opposite over hypotenuse. Then I have cos A, that is adjacent over hypotenuse. Adjacent here for angle A, adjacent is AB and hypotenuse is AC. So that will be 3 over 5. So this is the final answer. Now this is a problem number 6. It is given that in triangle ABC and triangle XYZ, if angle A and angle X are acute angles such that cos A is equals to cos X, show that angle A is equals to angle X. So first we'll draw this like you have this is our triangle, these are the two triangles. I'll take this as A B C and this is x, y and z. Now given cos A is equals to cos x. So according to A, it is adjacent over hypotenuse. So it will be AB over AC is equals to xy over xz. Okay. Now let us suppose that AB over AC is equals to xy over yz is equals to k. Now by using Pythagoras theorem, we have AC square will be equals to AB square plus BC square, and XZ square will be equals to XY square plus YZ square. Now what we will do is, we have ACAB, so we'll take this BC square is equals to AC square minus AB square, and XZ square equals to, sorry, not XZ square, we will be taking uh, YZ square will be equals to XZ square minus XY square. Okay. So now what we will do here is, we will take this as BC will be equals to root of AC square minus AB square, and YZ will be equals to root of XZ square minus XY square. Okay. Now AC square we got. Now from this one, AB will be equals to KAC, and XY. So here XY will be equals to K into XZ. Okay. Now you see here we have BC, that is equals to root of AC square minus AB I got as KAC, so it will be K square AC square, and YZ will be equals to root of X Z square minus XY is K square and XZ square. You take it this way. Okay. So now BC, we will divide BC by YZ, that will be equals to root of AC square minus K square AC square divided by a root of XZ square minus K square XZ square. So this becomes BC by XZ, YZ will be equals to, in this two I can take AC square common, so I am left with 1 minus K square divided by root of XZ square common, I left with 1 minus K square. This 1 minus K square, 1 minus K square gets cancelled. So I'll be getting BC by YZ will be equals to square root gets cancelled. It will be AC by XZ. So now we already have that AB by AC, we got it this way. AB by AC is equals to XY by XZ. And now you can see here we got AB. I'll take that implies it will be AB by XY is equals to AC by XZ, and AC by XZ is equals to BC by YZ. That means that implies triangle ABC is similar to triangle XYZ. So with this I can say that implies angle angle A is equals to angle X. Hence it is proved. Now student, this is the seventh problem. It is given that cot theta is equals to 7 by 8. So using right angle triangle, we'll write this cot theta ratio is given as adjacent over opposite. So if I am taking this as my right angle triangle A, B and C, if I am taking my angle theta at C, so this will be opposite, this will be adjacent, and right angle at B, so this will be hypotenuse. So opposite, first we have adjacent, that is 7 and this is 8. Okay, now by using Pythagoras theorem, we have AC square is equals to AB square plus BC square. Okay, now AC square will be equals to AB is 8 square plus 7 square. AC square will be equals to 64 plus 49. AC square will be equals to 9 plus 4 is 13, 113. AC will be equals to root of 113. Now we have to find out the first one. 1 plus sin theta into 1 minus sin theta divided by 1 plus cos theta into 1 minus cos theta. 1 plus sin theta into 1 minus sin theta, 1 plus cos theta into 1 minus cos theta. Okay, now so this is in the form of a plus b into a minus b, and the algebraic law for this is a square minus b square. So a plus sin theta into a minus sin theta will be 1 minus, sorry, it is 1 plus sin theta into 1 minus sin theta. So it will be 1 minus sin square theta divided by 1 minus cos square theta. Now sine is taken as opposite over hypotenuse. So here the opposite is 8 and the hypotenuse we got as 113. So 8 over 113 whole square divided by 1 minus 7 over 113 whole square. Okay, that will be equals to 1 minus 8 square is 64 divided by root 113 whole square means square root gets cancelled, it will be 113 divided by 1 minus 7 square is 49, again root 113 means square root gets cancelled, so it will be 113. Now we'll find out the LCM in the numerator as well as in the denominator. So we will be getting this as 113 into 1 is 113 minus 64 divided by 113 into 1 is 113, and the whole is divided by now 113 into 1 will be 113 minus 1 into 49 is 49 divided by 113. So this 113 gets cancelled. We are left with 113 minus 64 divided by 113 minus 49. So 13 minus 4 will gives me 9 and 10 4. 13 minus 9 is 4 and 10 minus 4 is 6. So our answer is 49 over 64. Now we are starting with the second bit, that is 1 plus sine theta divided by cos theta. So it will be one solution, 1 plus sine opposite over hypotenuse. So it will be 8 over root of 113 divided by 7 over root of 113. Cos is adjacent over hypotenuse. So adjacent over hypotenuse. Sine opposite over hypotenuse. Okay. Now when I find out the LCM here, in the numerator it will be 113. Root 113 into 1 is root 113 plus 8 divided by root 113 whole divided by 7 over root 113. So this gets cancelled. So we are left with 8 plus root 113 divided by 7. This is the final answer we got. We have our next problem, problem number 8. In a right angle triangle ABC, angle B is equals to 90 degree. If tan A is root 3, so I can write in this one, given tan A is equals to root 3. Every number has got a denominator of 1. So this is our opposite over adjacent. Now when I draw the triangle A, B and C, 90 degree at B. So we are taking tan A, so this is opposite and this is adjacent. So opposite is root 3, adjacent is 1. We have to find out hypotenuse. So by Pythagoras theorem, we can say AC square is equals to AB square plus BC square. So AC square is equals to AB is 1 square plus root 3 whole square. So that gives me 1 plus square root gets cancelled 3, that is equals to 4. So I got AC square is equals to 4, AC is equals to root 4 and that is equals to 2. So I got AC as 2. Now first one, sine A cos C plus cos A sine C. Okay, now for sine A, this is the figure. Now for cos for angle C, if we are considering C, A, B and C, this becomes opposite and this becomes adjacent. Hypotenuse remains as it is. Hypotenuse is 2, here it is 1 and this is root 3. Okay, so we can see both the figures. For A the top, for C the lower bottom one. So sine A, now in this one sine is opposite over hypotenuse. For A opposite is root 3 and hypotenuse is 2 into cos C. Cos C is the second one. Cos is adjacent over hypotenuse, so it is root 3 over 2 plus cos A. This is a cos A adjacent over hypotenuse, so this will be 1 by 2 or 1 over 2 into sine C. Sine C is opposite over hypotenuse, that is 1 over 2. So root 3 into root 3 will gives me square root of 9 divided by 4 plus 1 into 1 is 2 divided by 2 into 2 is 4. So square root of 9, 1 into 1 is 1. Okay, square root of 9 is 3 by 4 plus 1 by 4. Now you can realize that both the denominators are same, so it is a like fraction. We'll take a common denominator and add the numerator, so that gives me 4 over 4, that is equals to 1 whole. 4 1 times, 4 1 times. So you got the value of sin A cos C plus cos A sin C as 1. Now we are looking for the second bit of problem 8, that is cos A cos C minus sin A sin C. Now I have two figures also for angle A. This is for angle A and this is for angle C. Okay, so cos A is adjacent over hypotenuse. So for A, this is A, adjacent is 1, hypotenuse is 2. So 1 over 2 into cos C means second figure, this is adjacent root 3 over 2 minus sin A. So figure 1 for A, sin is opposite over hypotenuse. Opposite is root 3 and hypotenuse is 2 into sin C. Sin C is opposite, that is 1 over 2. So we'll be getting 1 into root 3 is root 3 over 4 minus root 3 into 1 is root 3 over 4. That gives me 0. So the answer is 0 for cos A into cos C minus sin A into sin C.